Our routers are broken up into different planes. We have our data plane, we have our control plane, and we have our management plane. What are the purposes of these planes? Well, the data plane is responsible for forwarding data. So data comes in an interface through the data plane to the exit interface, out it goes. In and out as quickly as possible across this data plane. Our control plane, what's happening there? Well, the control plane is where our routing protocols reside as an example. And these routing protocols do what? Well, they build the tables that are necessary to forward traffic down at the data plane. So you see the relationship here we have? We have that control plane doing the behind the scenes work that is necessary to build the tables and resources that are used by the data plane to forward the traffic. And then we have the management plane. That's the plane that's used for management purposes. Now, we have to understand here that if the management plane is compromised, that could potentially compromise the control plane, which could compromise the data plane. So we have to be aware of the ways that we can protect our management plane from various types of attacks. So the management plane being that point of access, console port, VTY lines, what can we do to protect ourselves from users accessing our device when they're not supposed to access our device? That's really important. So setting up access control lists to filter who is and is not allowed to remotely manage our device or even locally manage our device via the console port. But we also have to realize that the management plane runs at the process level. What does that mean? Well, the process level is referring to the CPU. The CPU is getting involved with everything related to management traffic, management functions and procedures. However, that is shared by who? It is shared by the control plane. You see, when we have routing protocols that exchange information with each other, and we have tables that are being built in the control plane, what is doing that? It's the CPU. The CPU is crunching the numbers. It's doing all the work. Well, that's being shared by the management plane. So if the management plane is overburdening the CPU, then the CPU can't be used to build the tables that are needed to forward traffic. So the control plane gets compromised, which then compromises our data plane after that because we have invalid information potentially at our data plane. So it's really important that we understand the different ways that we can protect our routers. Management plane. Number one, we could set up interface access control lists. Interface access control lists are just simply those ACLs that we apply to an interface, inbound, outbound. So we can control the traffic that's coming in and out. So by using extended access control lists, we can say, don't allow this type of management traffic, don't allow that type of management traffic. And we can do that. We can also set up service-specific access control lists. That's just the fancy way of saying we're going to set up an access control list and apply it to a specific service instead of an interface. Well, what's an example of that? Our VTY lines. You can set up the access class command on a VTY line and reference an access control list to control who's allowed to use the VTY lines. Same thing with SNMP. When you set up your SNMP server configuration, you can specify via an access control list what network management stations are allowed to access the device. Now, control plane protection is going to take us to the next level. See, with control plane protection, we can set up quality of service filters. Now, why would you want to do that? Well, with quality of service filters, we can manage the traffic flow of the control plane packets. That's right. With control plane protection, we can manage the traffic, that traffic flow for the control plane. Why do we want to do this? Well, if we can manage that traffic and monitor it, we have the ability to take specific actions if certain thresholds are breached. For example, if more than 100 packets per second are coming in from a particular service or protocol, well, then we could drop those packets. So that way they don't have to be processed by the CPU. So we can protect ourselves from having the CPU be overburdened or overrun by these particular protocols or services. So this is going to help protect ourselves from various reconnaissance attacks and even denial of service attacks that are being done to just simply bombard the CPU with so much information that it cripples and it can't do any of the other work that it needs to do. We also have management plane protection. And what management plane protection allows us to do is it allows us to restrict the interfaces that are allowed to accept those management packets. And by doing so, we have the ability to control at a more granular level, a finer level, as to what interfaces can be used for management access. So now we are ensuring that certain interfaces are never going to be burdened by management traffic. They're simply going to be able to just do their job and forward the data traffic that they need to forward. So we get a lot of benefits by controlling the interfaces that are allowed management traffic inbound. We can get many benefits by using control plane protection, setting up those quality service filters, and then on a granular level, just specifying who is allowed to do what when it comes to various services from a management perspective.